Okay, so just similar to the way that I had discussed the AIA versus the AIA converse, this is kind of similar to that. And this section is about ways to show that quadrilaterals are parallelograms. So instead of being given that a shape is a parallelogram and then your conclusion is like opposite sides are congruent or opposite angles are congruent, now what you're given is just a quadrilateral and it says show that that quadrilateral is a parallelogram. So I'm going to prove one of the properties with you guys. I think I only do one proof here. And then the rest of it are, we're just going to go over the properties that you might already know of yesterday and kind of summarize the ways in which you guys can show that a quad is a parallelogram. Okay, so one of the things we learned was by definition, so the definition of parallelogram, that first statement up there, provides one way to prove that a quadrilateral is a parallelogram. The following theorems provide 4 more ways, and in fact, there's actually one additional one that I'll go over as well. Okay, so we'll summarize all of this and then summarize it again in a picture. So with the first proof, if you read the statement, you'll notice that it's actually the converse of what you guys studied on the very first page. So if we read it, we say, if both pairs of opposite sides of a quadrilateral are congruent, then the quad is a parallelogram. Think back to the first page. The first page was, if the quad is a parallelogram, then your conclusion is that opposite sides are congruent. So what we did was we switched the if and the then statement. So this is similar to like the converse. So in this proof, now for your state, we're going to prove this one and then accept the other ones. So statements and reasons. My first statement is this time, it's the opposite of what we were trying to prove, right? This time they're giving us that the opposite sides are congruent. And we're trying to conclude it's a parallelogram. So given, we're going to draw our auxiliary line to help us with this proof. So go ahead and draw that. I won't actually write that into the proof. It was just done to show you guys that that's something that you can do to a diagram to help you with the labeling of things. So in the angles, we're going to also label it by numbers. So 1, 3, 4 down here, and then 2 here. So go ahead and label those. And also mark off your given. TS is congruent to QR, and TQ is congruent to SR. Okay, I want to show, if I want to show something is a parallelogram, it goes back to that one homework question that you guys just asked me about the definition of parallelogram. So what makes something a parallelogram is that the sides are parallel. So I'm going to want to somehow use, if I'm trying to prove lines are parallel, I'm going to somehow use those converse ones, either corresponding angles or AIA. But in the picture right here, we can see that we have several, what type of angles, you guys? Just kind of working backwards here. What angles do you guys have that might help us prove that the lines are parallel? Do we have corresponding angles? Do we have same side interior angles? Do we have alternate interior angles, alternate exterior angles? Okay, so yeah, I want to keep in mind that I have a couple of 2 pairs of AIA angles, and that's going to help lead me to conclude that the lines are parallel. So let's work with that. Okay, so this is very similar to the proof you guys did last night. So if I'm trying to prove that those triangles are congruent, what would the second step be here? If you guys are trying to prove that the 2 triangles are congruent, what would your next statement, what would be logical in your next statement? Yes, good. Reflexive property, right? We want to establish that QS is congruent to itself. The shared wall is congruent to itself. Very good, by reflexive property. And so then I know that now I know that triangle QRS is congruent to triangle STQ. And what's the reason for the 2 triangles being congruent? Okay, all 3 sets of sides are congruent to each other. Very nice. So side, side, side. And then within the, so we not only know that the 3 sets of sides are congruent, we also know now that the angles are congruent to each other. So we know that angle 3 is congruent to angle 4, and that angle 1 is congruent to angle 2. Here's where I see mistakes happen on step 4. Would the reason be for angle 3 being congruent to angle 4 and 1 congruent to 2, Would it make sense to say that that's because of CPCTC or because of AIA? Think of your step before. Okay, I'll read what one student wrote. CPCTC because the lines aren't proven to be parallel yet. Okay, so you guys don't know that the lines are parallel yet, so you can't say that it's true because of AIA. So remember that once you guys prove that the triangles are congruent, you're listing out parts of the triangle of two triangles that are already congruent. So this is CPCTC. And then now that you know that those angles, which happen to be alternate interior angles, are congruent to each other, your conclusion is that now the sides are parallel. So that TQ is parallel to SR and TS is parallel to QR. What might the reason be for this one? What do you guys think? Yes. Okay. So very nice. This is the one that you guys missed on the homework last night, some of you. So this time when we're trying to use the alternate interior angles to prove that the lines are parallel, this is the converse of AIA. Good. Good review for your final too. Okay. So since the lines are parallel, now I can conclude that the quadrilateral QRST is a parallelogram. Why do you guys think it might be a parallelogram if in the step before that you guys had that the lines were parallel? What do you guys think? Is it yes? So think of what we started this whole chapter with, right? The definition of parallelogram has the word parallel in it. So if the opposite sides are parallel, then you can conclude, very good, that by definition of parallelogram, that quadrilateral is indeed a parallelogram. So that's going to be one way you guys can show, and we're not going to prove it, but we're going to show that something is a parallelogram is by showing that opposite sides are congruent. The other way is if one pair of, so these ones I'm going to have you guys draw a picture, an if-then statement with a picture. So there's also one where you guys can simply show if you have a quadrilateral that one set of opposite sides, okay, one pair of opposite sides, only one pair instead of both pairs, are both congruent and parallel. And this one I tell students that you know the one pair of opposite sides, since it's only containing one pair of opposite sides, that two things have to happen. It has to not only be congruent, but parallel. You don't have to know anything about the other side, the other pair of sides. So according to this theorem, you would conclude that if you had a quadrilateral that had one pair of sides, both congruent and parallel, then this shape means that it's a parallelogram. Okay, so then your quadrilateral is a parallelogram. And what I'm going to do is just draw what I know to be a parallelogram by definition, right? That both sets of sides are parallel. Okay, so let's draw the next one. The next one should be familiar to you guys because that's the other one that we learned. So there's a typo here. We already did sides. Yesterday, we also said that if we're looking at a parallelogram, opposite angles are congruent. So if you know both pairs, so this one has both pairs. So go ahead and draw a quadrilateral, and we'll say that both pairs of angles, which means that what you see in your diagram would be this, are congruent. Then your conclusion is that that quad is a parallelogram. So again, we have opposites, both pairs of opposite sides congruent, or both pairs of opposite angles congruent, or one set of sides is parallel and congruent. And then the other property that we had learned yesterday was that about the diagonals, right? So let's go ahead and draw a quad. And within this quad, let's say you notice that the diagonals bisect each other. Okay, we would signify that they bisect each other by marking off the segments as congruent. then that quad is a parallelogram. I'll give you guys a few seconds to just summarize that. Okay, not all the properties were mentioned here. And so what I'm going to do is just summarize all 6 for you guys on the next page. Sorry, did someone have a question?
Oh, I didn't get to finish my notes.
Oh, sorry. Here, let me go back. And let me know if you're ready for the person who unmuted. I couldn't tell who unmuted.
That's it. Thanks.
Okay, no problem. All right, you guys. So on the top of the next page, this is our last page of notes, and I'm going to let you guys work together in breakout rooms to start off on your homework, because I know these types of questions it's good to have conversations about some of those problems, and I want you guys to be able to ask each other about it. So on these 6 problems that you got, or 6 ways to prove that a quadrilateral is a parallelogram, I'm going to write out some of the 6 different ways. And you're not technically writing a proof, but these are reasons for why you might justify that a quadrilateral is a parallelogram. Okay, so you would, so I'll start with each one of these with the word show. Okay, so by definition, you guys can show that both pairs of opposite sides are what, you guys? If it's by definition, you want to show both pairs of opposite sides are, what do you guys think? Are fill in the blank. If it's by definition, So think of the definition of parallelogram. Good. Okay, so by definition, if you are able to show that both pairs of opposite sides are parallel, and I'll put definition here. And for that one, you guys can say, oh, we know by definition of parallelogram. Okay, number 2, you guys can show what we proved on the first, on the previous page, right? What else can you guys show? That opposite sides are, besides parallel, that they are good. Okay, what else? So we have show both pairs of opposite sides are perfect, that both pairs of opposite sides are congruent. So these are various ways that you guys can show it, okay, so that are congruent. We can also show both pairs of opposite angles are what? Are same side interior angles, or sorry, are supplementary or are congruent? If they're opposite angles, what would you guys want to show? Okay, opposite angles are congruent. Very good. Then we can say show both. First, actually, let's do the diagonals. We want to show the diagonals do what to each other? Show that diagonals. Okay, very nice. Bisect each other. Let me pause so you guys can write what we have down. Okay, there's two more left. One of them I didn't mention on the previous page, but there was one that you guys learned yesterday about angles. Okay, so one about angles. Very good. We haven't mentioned anything about consecutive angles or same side interior angles, right? And in some textbooks, they don't list this one out as a reason. The reason being the same side interior angles, if you are able to show that they are supplementary, then you've proven that the lines are parallel, and then it goes back to this reason. So some textbooks don't list this out as a reason, but I like to have it here just so you guys, when you're looking at a picture and you can tell that they're supplementary, that you automatically know that it's a parallelogram. So show that two pairs of same side interior angles are supplementary. Okay, so you guys, there's the word both, or show that both diagonals, two pairs. There's one that has only one pair in it. Okay, so show that one pair of sides. So the one that has only one pair of sides has two things that has to happen, right? Show that one pair of sides are what? Are both blank and blank. So as you guys are writing this out, hopefully absorbing it and just remembering it, because it makes it so much easier if you guys already have this portion of it memorized. So good. The one pair needs two things to happen: congruent and parallel. So the way that the problems will look for this section for tonight's homework is they might give you guys a diagram. And at first, you're going to assume that it's just a quadrilateral. And then the question is, do you have enough information based off of the picture to conclude that it is a parallelogram? And all I need you guys to be able to say is yes, because diagonals bisect each other, or yes, because both sets of sides are congruent. Okay, something to that effect. Okay, so when you're looking at the number, let's start with something easier, like number 3. For number 3, what do you guys think? Yes or no first, and then if yes, can you guys state a quick reason? Perfect, Cody. Okay, so some people, yeah, all they did was write 3 words, which is correct. If you guys look, the diagonals are marked, the diagonal segments are marked congruent to each other. So yes, this is the reason above for diagonals bisect each other. Okay, so something short and concise like that. Perfect, you guys. Thank you for responding in the chat. Okay, let's go back to number 1 now. Okay, so what I would do is mark that 6 is congruent to 6. So for sure, we know that the opposite sides are congruent. Now what I'm going to look at next is, well, I can't make certain assumptions. Like I can't say like, I know that this is going to be congruent to this, because we don't know that this is 75. So we don't know that that's true. So we can only go off of what we're what we're given. So if I drew these lines out, what type of angles are 75 and 105? Okay, good. Someone typed in their same side and their supplementary. What conclusion can you guys draw? If they're same side and supplementary, what does it mean about these lines? So if same side interior angles are supplementary, yes, by converse of SSI, I would know that these lines are parallel to each other. Very nice. So when you mark that, now you guys know, is this one a parallelogram? Is this a parallelogram? Yes, because of the way that I marked it, if I had to select the reasons from above, it's reason 6, right? Yes, because one pair of sides are both congruent and parallel. Okay, so you guys see how we did that? You want to see what conclusions you can draw, and then if it's enough information. And don't, I don't know what the word is, but don't conclude too much about a picture based off of things that you're just assuming. So like number 2, for example, 1 was legitimate, what we did. Number 2, let's say you guys marked off 12 and 12. What do you guys think? Do you guys have enough? 100 and 100 just simply means that this is congruent. Is this enough information to show? Does this give you guys any other information in which you can conclude steps 1 through 6? Yeah, it doesn't look like it. You have one set of opposite angles being congruent. You have one set of opposite sides. That's not anything that's conclusive for us. Now, someone said, how about if we just said this was 80? Okay, so we can't assume that that's 80 because that's assuming that we knew those lines were parallel and that they're same side interior angles, but we aren't told that in the picture. So this one is no conclusion for this. Okay, sometimes your pictures are given to you guys in terms of statements, and then it's just one picture. So step 7, 8, 9, 10 is just yes or no as well. Let's say on step 7 or question 7, you guys are given AU is half of AI. So AU is half of AI as well as OU. OU is half of OE. Yes or no on 7? Okay, good. The diagonals ones is the one that we're gonna hopefully think is the easiest one to recognize. Yeah, if it's half of it, then that means that the diagonals bisect each other. So we are able to conclude. So yes, diagonals bisect each other. Okay, number 8. Okay, on number 8, you guys have EAO. Okay, EAO is equal to EIO, and AOI. These are not easy to say. AEI. Yes or no, you guys? Yeah, that's what I feel like I was saying, Gavin. Okay, good, you guys. So we said yes, and this is because opposite angles are congruent. And notice that the difference between number 8 and number 2 is that both sets of opposite angles are congruent. Okay, I don't think I need to mark off number 9. What do you guys think about number 9? Yes or no if you guys know that opposite sides are parallel. Good, by definition, right? So opposite sides are parallel. Perfect. Number 10. This one I'll mark off. This is your given EAI is congruent to AIO, and that AE is congruent to OI. What do you guys think for this one? Yes or no on 10? If you guys typed no initially, what type of angles are these angles that we marked? What type of angles are those angles, and what conclusion can we draw? Yeah, if they're alternate interior angles and they happen to be congruent, then exactly, then one conclusion we can draw from that is that by converse of AIA, we know that those opposite sides are parallel, and they also were given as congruent. So actually, yes, because one pair is both congruent and parallel. Okay, so then there's some variable ones. Let's do a few of these together. 11, 12, 13, 11. Let's say you guys were looking at this picture and they said solve for x and y such that the quadrilateral is a parallelogram. So here you're going to make all the assumptions that you can about this being a parallelogram. So the first step is, let's say you guys are looking at 11. Would you guys say that you would start by solving for y for this, or would you start by solving for x? But does it make sense to actually, there's more than one way to do the problem. Either one, yeah. Okay, either one. If you were to choose to solve for y first, then can I have you guys use what you know and solve for y? I circled it. So go ahead and solve for y and type out what you guys think it is. Okay, once you guys solve for y, x is a little bit harder though. One person who answered for x, I don't think x is correct. So when you guys are thinking about x, you have a couple of things you can do. You can either plug 41 back into this and understand that this whole thing is 123, or you guys can go in this direction. What type of equation would you guys set up for the relationship between 2x minus 5 and 123? What's true about that? Those two angles. Very good. Yeah, so two ways of doing this problem. Very nice, the people typing it in. One, you guys can do 2x minus 5 plus 123 is equal to 180. Other people I saw took 180 and subtracted 123. They did that step and then set it equal to 2x minus 5. So go ahead and solve for that equation and tell me what you guys think the answer is. So once again, that you could have done the 180 minus 123 in your head and then solve for it. Yeah, maybe double check some of your work again. Some of you guys, I think you had maybe a typo on your, not a typo. I'm used to thinking of typo as in typing in your answer, but just double check. Okay, yeah, I think that person caught their mistake. Okay, divide by 2 and you guys get 31. Very nice. The majority of you guys got that correct. Okay, so 12 I'm actually going to skip because I think that's easy enough for us to figure out. If 13 is a parallelogram, can I have you guys first start by solving for x for me? For 13, can you guys solve for x and type out what you think the answer is? Perfect, so that one should be pretty easy. Okay, alternate interior angles because those lines must be parallel to each other. So x must be equal to 15. Can I have you guys solve for y next? Okay, perfect. Y equals 7. All right, you guys, in the chat, 1, 2, 3, 4, or 1, 2, 3. 1 is fairly easy, 2 medium, 3 difficult. How do you guys feel about this lesson? 1 is easy, 3 is difficult. Okay, between a 1 and a 2, some people are saying it's easy. And then I will say that I think because the next lesson is a little bit longer, I was debating whether to start the next box with you guys or just wait until the next day to start that lesson. But I think what I'll do instead is just have you guys draw a diagram that hopefully will help you guys out instead of, so it's a little bit more visual for the reasons why. So if you guys can have a blank sheet of paper out, and then I'll end with that. It's a quick drawing that I'm gonna have you guys do. So if you have a blank sheet of paper, if you guys can hold it landscape for me, let me add a page here. So blank sheet of paper, make it landscape. Do you guys know what I mean by landscape? So just the way that the screen looks, right? We're going to flip it sideways. Okay, and then I liked having this as a graphic organizer. What we're going to do is just take about, if I was looking at a paper, this would be like a third of the paper. Let's say you guys were holding it landscape. And then you're writing at the top, is it a parallelogram? At the top like that. Okay, because then after today, we're going to learn about all the special types of parallelograms. So today was just, is it a parallelogram? And then I'm just going to have you guys draw the 6 different ways. So one of the ways was by definition. So go ahead and draw a parallelogram or a quadrilateral with opposite sides parallel. So this is all just a visual of the 6 different ways that we had. And so that way, when you guys go back to study, you have like this little sheet with you. Is it a parallelogram? Sure, if opposite sides are parallel. If opposite sides are congruent, here's another way. Third way, if opposite angles are congruent. Fourth way, diagonals bisect each other. I'm going to stop right here and see what else am I missing, you guys? What else am I missing? Those are 4 different ways. Those are the 4 most obvious ways people usually remember. Okay, 1 pair, congruent and parallel. So go ahead and draw that diagram as well. And perfect, the same side interior angle. And this one, I think I wanted to draw this for you guys. When I was thinking about making this graphic organizer, I thought this especially this last diagram, it would be most useful to see. For this one, you guys would have to show that, and I'll give an example here, that this set of, because what I drew right here only means that this set of lines are parallel. So when I say 2 sets of same side interior angles are supplementary to each other, you want to make sure that that the 2 sets prove that opposite sides are parallel. So meaning that in this first 2 sets, or this first set right here, 75 and 105, those 2 are going to prove that these 2 lines, the left and right one, are parallel. This set of same side interior angles, 75 and 105, is going to prove that the top and the bottom are parallel. So that's going to be kind of like the picture that you want to see when you're thinking about same side interior angles being supplementary. Yeah, let me see if I can zoom out a little bit here.